Why do we create new programming languages? And it can't just be to give instructions to computers. If it were just that, we could have stopped at C, I think. We don't create new languages because computers are changing. We're creating them because we're changing. Our expectations of what should be easy, what's normal, are changing. Take, for example, asynchronous function dispatch. It's been around for decades. It was always awkward, and you didn't use it unless you really had to. Until JavaScript came along with its single threaded execution model and its massive popularity. We were kind of all forced to learn about callbacks, which were powerful but painful. And eventually we got promises and generators and async await, and the language evolved so that the technique became fairly pleasant, fairly natural way of expressing certain tasks and solving certain problems. But in all that time, it wasn't the computer that changed. It was our ability to express ideas through language that changed to make something more usable and more pleasant. And that's what interests me about new programming languages. We're evolving as computer users. Since the 1950s, our needs have been changing and our base level of knowledge has been changing. How are our languages and tools changing to support that? Joining me to discuss that and to throw his hat in the ring is Yorick Peterse. He's the creator of Inko. Inko is a language that expresses his ideas about how memory management can hit a kind of power and control sweet spot that Rust is missing. How can we make concurrency easier in a typed programming language? How should exceptions work? Should they exist at all? And mixed in with those specific topics, we ask some broader questions about language design, such as, if you're interested in getting involved, how do you learn this stuff? And how do you fund it? And what's the future of open source funding anyway? Let's find out. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Yorick Peterse. Yorick, thank you very much for joining us.
Yes, thank you for having me, Chris.
It's a pleasure to have you here as one of the world's increasing number of fascinating programming language designers. Thought I'd get you in and pick your brains about it. So I think the starting point for this is what's your target audience? What kind of language are you trying to build, and for whom?
So the target audience, it's kind of the people that are currently using languages like, say, Go, Erlang, Java. The kind of, I would say, like mid-level-ish languages where they give you more control, like compared to, say, Python, Ruby, and such, but they don't go all the way to Rust, C, that sort of level. But then people who are using those languages and they're looking for something that doesn't have, say, the promise that you typically have with a garbage collector. They're looking for better concurrency support, but they're not willing to go as far as, say, Rust. Like, Rust is an excellent language, but it does take a lot of mental cycles to work with.
Complete control, but expects you to join it in its model of the world, right?
Yes, I would say ultimately it's kind of typically with that sort of gap, it's very unbalanced in that you jump to a low-level language and the sort of scale of, I would say, ease of use, productivity, etc., versus the performance, the trade-offs, etc., it's quite unbalanced. And so Inko sort of sits in the middle of that, where it tries to give you a language with automatic memory management, but without a garbage collector. So you don't have to spend, days, weeks, whatever, tuning it. It gives you various built-in sort of concurrency mechanisms so that you get memory safety as part of your concurrency. And so it ends up kind of borrowing things from different languages. such as Rust, Pony, Erlang, and it's sort of ultimately the idea is that if you are looking for something a little more, but you're not willing to go all the way to Rust, Zig, etc., I think Inko would be a very interesting choice there.
Okay, I see. I'll nail my master the fence. I'm not even sure what the metaphor is. I'll show you my cards. I really like Rust, and I can see that the cost of learning it is worth it. But I can also appreciate that not everyone wants to go all the way there. So I definitely see an ideas market for something that gives you some of that control, but not all of it. The question is how. So maybe we should go through your list one by one, right? How do you do? What's your memory management approach if it's not garbage collection?
So it is single ownership. It is, in that sense, similar to Rust. The big difference there is whereas Rust uses lifetimes and a borrow checker, Inko doesn't. The sort of core principle is that at its foundation, it essentially uses reference counting. But then using single ownership, the reference counting is only used for borrows. And instead of the traditional mechanism where you just release when the count reaches 0, the way it works in Inko is that if the owned value is dropped, it will check, hey, is the reference count 0? If so, we're good. If not, it will terminate the program with an error. And so it's not quite borrow checking at runtime, in that Inko allows you to have, say, multiple mutable borrows. It's more like, hey, are there still any dangling references? And then the sort of long-term idea there is to, through compiler optimizations, remove as many of those actual reference counts as possible, so that it doesn't affect the performance, or at least as little as possible.
And thereby, presumably, stops so much of the semantics of that leaking into programmer space.
So it doesn't. It's not really like leaking in terms of how you write the code. Like if you're writing code, you're not really think like, oh, this is reference counted. It's very similar to Rust in that you have your own values, your borrows, etc. The difference is that Rust checks everything at compile time, and that's on one end a big benefit of it, in that if it compiles, to a certain degree, it will work. But that's also where all the mental cycles go. And that's where certain patterns are very difficult or simply not possible in Rust. And Inko's approach to sort of defer some of that to runtime is that the goal there is to sort of provide a better balance. Like you sacrifice some sort of compile time guarantees for an increase in productivity, ease of use, etc. And then, through optimizations, reduce the cost, and perhaps through additional compiler analysis, I think you can get, let's say, 70-80% of the cases where you'd have some sort of borrow error, you can detect those at compile time. So you end up with a language that, at least in my mind, is more approachable compared to Rust, for example. Of course, not without its own trade-offs.
Is there, for that guarantee that you're giving up, is there any sort of language-based support to try and nudge you back on the safe path?
So in what sense do you mean in terms of...
It sounds to me like you're saying, if I have a value and someone else mutably borrows it and I drop it in my local code, it's going to blow up at runtime. Is there anything like a compiler warning that says you might want to check that you got that borrowed thing released before this point?
So not in its current form. There is essentially that doesn't exist. The thing there is, unlike Rust, for example, it is perfectly valid to have multiple mutable borrows or immutable. There's no what's called the XOR rule in Rust. It doesn't exist. And the way this is safe in Inko is that values are heap allocated by default. So they are in a stable location, so you can move them around while borrows exist. And for concurrency, it takes a different approach in that the way values are sort of moved between tasks means that when you move it, there's a guarantee that whoever is moving it, the task that it's moved from, cannot have any borrows to it. So you basically know as this value moves between the boundaries of different tasks, the compiler guarantees statically that that is safe.
Okay, so we're getting into the concurrency thing. You've got this mechanism which seemed to me to be a bit like, say, Go routines, or almost a bit like the actor model with like channels of sending data to places. You're guaranteeing that something can go down that pipe safely, a compiler.
Yes, it's a mixture of Erlang and Go to some extent, and Pony. Pony is perhaps a lesser known language, which it also does actors, inspired also by Erlang. What Pony did, it put a whole bunch of sort of different reference types on top of them, capabilities as they called it. And they describe what you can do with values, how they can move between tasks, etc. Inko borrows from that to some degree, where it has this notion of recovery. Essentially, what it means is you have this sort of block of code, and values created inside of it do not have, or have very restricted access to values created outside of it.
Right.
And so what happens when you return a value from that block, the compiler can guarantee like, hey, there are no outside references to this thing. And so it's safe to then move it around between threads. And so it's this mixture of the actor model, where processes, as they're called in Inko, they are isolated. There's no sort of implicit memory sharing, no global state. And then it uses this recovery mechanism from Pony to guarantee that it's safe to move values between those processes, rather than, say, what Erlang might do is copying them. Or in case of Rust, you have to use, say, synchronization, or what they call scoped threads that have essentially read-only access to certain data.
Right. So you're building a system where it's safe to pass the data logically from one process to another, and yet still reuse exactly the same piece of data in the same memory space.
Yes. Yeah. So in a at some point during Inko's development, it was using a model closer to Erlang, where values were basically deep copied as they were being sent between processes. But this poses a problem where, for one, it's quite expensive, depending on how big the data structure is. And certain values you cannot copy safely, or like, it's not the right term. They have side effects. So if I have a file descriptor, for example, and I want to copy that between processes, that copy process can fail if you run out of file descriptors. And so this poses a question like, okay, how at the language level would you handle this? Is this something that users should be concerned with, knowing that most of the data they'll be sending will never fail? So you end up with this pattern where you have to handle errors that realistically will probably never happen. And that sort of, over time, pushed me towards this model of trying to figure out, okay, how can we move this data around without copying? And then that way we sort of sidestep that entire problem. And that's sort of how it ended up with the current approach. But you can, of course, still copy. Like if you want to, you can explicitly clone an object and then send it over.
Okay. That makes you wonder, like, there you are, with the previous model thinking, I prefer the way that did you say it was Pony that gave you that idea?
Yes, I don't quite remember how I ran into it. I think I sort of started looking for alternative approaches, and I knew about Pony already, and yeah, somehow I ended up looking into it. I read this paper that is based on. Fortunately, don't remember the title.
That's what I was going to ask you. I was wondering how it is you learn this stuff. Never mind deciding which thing to do, but how do you learn to then implement it?
So, in case of Pony, there's Pony as the language, and there's the paper it's based on. It's I think a paper from 2012. I honestly don't remember the title, but I'm fairly sure the Pony website links to it, and I think Inko's documentation links to it from somewhere as well. But basically, that paper describes this model where you have this recovery mechanism along with some other extra sort of reference constraints, capabilities, whatever you call them.
Hmm.
And then Pony took that and they added additional stuff on top. And so Inko sort of did the similar approach where it took some things from that paper, but then kind of doing the opposite, where you say we were not going to add all these capabilities. Because I think one of the problems with Pony is that because it has so many capabilities, it's quite a tricky language to use. At least that's the feedback I've seen over the years of people saying, "Oh, hey, this looks interesting, but I can't wrap my head around it."
Okay.
So with Inko, it's like, no, I'm only going to take sort of the essential bits needed for its concurrency system. As far as sort of learning, it's for some people, what they'll do is they'll read the paper and then they maybe try to implement it. I tend to struggle reading scientific papers.
That's fair. That's a honest confession that a lot of us
Yeah.
would struggle to confess to.
And it's part because even though English is my second language, it is still not my native language, and academic English is a whole different level.
Yeah,
and a lot of papers are very dense in that you read a sentence, but it's actually 5 sentences condensed into a single one.
yeah.
So it's a very time-consuming process, and I can make it through like a small portion and then I just lose interest basically.
So what do you do?
I basically bang my head against the wall. Very long time.
The old programmer solution to everything.
Yes, I don't have any secret tricks there. It's a lot of frustration, a lot of trial and error, and trying it over and over and over and over and over. I think in this particular case, because Pony existed, there was a sort of reference that is a bit easier to digest. Like you can actually play with and see, like, oh, okay, I can see what they're doing here. And I don't quite remember how I made my way through it. I do remember that in the end, you look at it, it's like, oh, okay, actually, this is not that difficult.
Yeah.
It's like you spend 5 days on something, and the end solution is like, let's say 10 lines of code. That's sort of equivalent. Like, wait, did I spend all this time on that?
Yeah.
And I think that's the beauty of this particular recovery mechanism, is that it's so deviously simple. You look at it and you're like, okay, that it took a lot of effort to understand this paper, describing it and going through it, but in the end, it's actually fairly straightforward. And that's with building Inko and a lot of projects in general. That's sort of my way of going through it. That I try to find existing references, papers, tools that implement things, etc. But a lot of it comes down to just banging your head against the wall over and over, sort of brute forcing your way through it, which I'm sure there's more efficient ways of going about it. And I do sometimes wish that I had more academic knowledge. But I've also kind of accepted, this is the way it is. This is a big part of programming, unfortunately.
Yeah. Often if I want to understand something, I find the only way to get it into my head is by bashing it through the keyboard. Right? And it's like these things where programming is both the art of constructing working software and a process that helps you think more clearly about a domain.
Yeah. It's, I think a lot of people, when they are sort of getting started with programming, they might think that it's this sort of rigorous, well-defined process. Like, you have your hypothesis, and then you do your research, and then you build. It's like, no, it's more often than not, it's like banging two rocks together until you get sparks, and it's like, I made a fire.
Yeah. I often, sometimes I speak to junior developers, and they say I feel stupid, and it's like, congratulations, you're doing it right.
Yes,
that's the process.
It's funny because my partner is going through this where she's getting more and more into programming. She has a data science background. And she'll, from time to time, come over with these problems. And she's like, hey, I don't understand this. Am I just not getting it right? Or I feel stupid or whatever. I'm like, congratulations, welcome to the club. This is what it's like.
Yeah.
This is your career from, for the next, I don't know how many years.
Yeah. Look out for those brief moments where you feel like a genius before the roller coaster begins again.
That's where you have to be careful. That's where it's like, okay, wait, am I a genius, or is this my ego getting the better of me?
Yeah. It'll be around soon enough. Yeah. Okay, so this could be a tricky question. It could be a test, but so this recovery algorithm. Can you explain it to me?
Yes. So at the basic level in Inko's memory management, we have owned values and borrows. Owned means you move it around, you're done with it, it gets dropped. Borrows, they don't. They just temporarily give you access.
Is this like? I mean, I would imagine that a local variable is definitely an owned variable.
So, for example, if you do something like, hey, create a new instance of a user, that will typically default to owned. Right. Well, if it's just new, just create the instance of the object, yes, it's owned. If you then assign it to a variable and then assign it to a new variable, it will get moved so that old variable is no longer accessible.
Okay.
So in that sense, that part is exactly like Rust. The way recovery sort of builds on top of that is there is in the language, a recover keyword. And you give it basically a block, a scope, whatever you'd like to call it. Within that block, values defined outside of it, as sort of a basic implementation, they are not available. So if you imagine you have a variable called a user, and you assign it a instance of a user type, and then you do recover. And inside that recover, if you refer to that user variable, the compiler will say, you can't access it. It's not, in this case, quote unquote, sendable.
Right.
Sendable being a term like, hey, it is safe to move between the boundaries of tasks.
Right. Okay.
Within that recover block, you can just do things as usual. You can create new instances, call methods, yada, yada, yada. Provided, if you call, say, a method on a value, if that value is defined outside of the recover, it will say, can't do that.
Yeah.
That means that when you exit that scope, the only data you can have access to is defined within it. Which then also means that if you return something, then everything that's not part of that is discarded. So if I have a recover block and I create, say, user Alice and Bob, assigning to variables, and I return Bob, then the compiler will know, hey, Alice is no longer in use.
Okay.
What that means is that at the point of returning a value from that recover block, the compiler knows, because of that there can be no outside references to that value, because they will be discarded as you return from the scope.
Mm.
Now, there may be references, borrows inside of that value that you're returning, pointing towards the value itself. That's perfectly fine. And if there are borrows in that value pointing to other values in the recovery block, that will trigger a error at runtime in this case, because it will say, hey, you're maintaining a borrow to a value that's being dropped. So in other words, if let's say you have Alice and Bob, and you return an array of, let's say, borrows to Alice and Bob, it will say, hey, you can't do that, because while the array will survive the recover block because we're returning it, Alice and Bob will not, because they're being discarded.
You've got like dangling pointers, the equivalent
right.
of. Yeah.
And so you end up with this sort of guarantee that at the end, because there can be no outside references to it, and because sort of interior references are contained within the value, it is safe to move it around. And so what the compiler does at that point, at the end of the recover block, it will take that value and it will type it as unique. So instead of a user, it will be a unique user, for example.
Okay.
And that basically means, hey, this value has that guarantee, no outside values to it, can point to it. Inko then builds on top of that by, under certain conditions, sort of loosening up those restrictions a bit. So, for example, if you have a owned value defined outside of it, it will actually let you access it, but in very restricted forms. So you cannot mutate it. You cannot borrow it in ways that would allow that borrow to be passed around.
Right.
There's some rules that allow you to call methods on those values. That's basically a set of exceptions where if we know, hey, it is safe to allow X, Y, Z, we do that. And the idea there is that if you have, say, a unique value, without those relaxed rules, you couldn't really do much with it. You can just pass it around and you can turn it back into an owned value, but that's about it. And so by relaxing the rules in certain cases, you can still call methods on it, and to a certain degree work with it as if it was just a regular owned value. And that's sort of the basic gist of it, in that you have a scope, and at the end, so you have a scope, you cannot access data outside of it. At the end, that does means the only data you return was created inside of it. And then through its sort of borrow guarantees, the compiler knows, hey, it is safe to do this, and thus we can pass this value between tasks. The exceptions there are a little more tricky. Happily discuss them, but that's where things get a little more difficult.
We're definitely getting into that. But let me just check. So it sounds like this recovery area, it seems naturally suited to things like when you create like constructors, right?
Right.
That seems like a natural fit. Where else is it useful?
So in the way you would use this, typically only if you intend to send values between processes.
Right.
So if you have, essentially a single threaded program, you would pretty much never use this. And that's also part of the beauty, that this recovery mechanism is fairly simple to understand, but it does impose certain restrictions. And the nice thing about it is, if you have no need for it, you never have to pay that cost.
Right. Yeah.
It's only when you need it that's where you have to say, okay, wait, hold on, we have to deal with this.
So is this when, like, I'm going to get into concurrency, I think, when I want to set up a channel between two processes, I'm about to send a message across the wire. Now I will go into this recovery area to create a message I know is isolated from everything else.
Right. Yeah, so that's where you basically use it. The way you'd sort of typically go about that is, at least in my experience, it's quite rare where you create a value in some random place and you use it through all sorts of parts of your program, and then somewhere deep down you're like, oh, we have to send this to a process, without you really knowing about that up front. So what you do is, either you create this unique value sort of early on, and you still, you pass it around. You can use it because of how the compiler relaxes certain rules, and then you can just pass it around. And then when you say, hey, I want to have full access to this thing again, you can sort of recover it back into an owned value. The other approach is you can clone it. So if you have a owned value, the way recovery works is that because of these relaxed rules, you can do something like, hey, take this user, clone it, but do that inside a recover. And then the compiler knows, okay, because of these restrictions we apply, that copy is now safe to move between different processes.
Okay.
It can get tricky where if you have a value, you use it in a bunch of places, and then at that somewhere in the middle, you have to turn it into a unique value, and you cannot go back and do that earlier. That's sort of a challenge where if you have to pass values between processes, you do need to think about that sort of closer to where you create them. But I found there are not that many cases, if any, where you cannot say, hey, we're creating this value. Oh, we have to share it. So move it between processes later on. Let's create it as a unique value.
Right.
And the nice thing there is you, as let's say, an author of a library, you do not have to think about this. So if you define a type and it has a new method, for example, you don't have to think, oh, I want to allow people to move this between processes. So I'm going to return a unique instance of this type. You don't have to do that. You just return your normal thing. And that's because those methods, if you use them inside a recover, the compiler will do that for you.
Right.
And so you can write entire libraries that just do not care about any of this, and you can still use them in a sort of concurrent setting.
Right. And to reconnect this, the point of all this is that we can get something like a garbage collected experience, but without the performance hit of garbage collection at runtime.
Yes. So the goal there is to sort of provide a balance between sort of ease of use that you get from a garbage collector language, but without the penalties you typically pay. Now, of course, that comes with its own trade-offs. It's not something where if you use to say Python, you can't just jump in and immediately start working with it and not have to learn anything new. There's a bit of learning involved. But overall, there's the idea, like it shouldn't be that you sort of hit a wall and I have to really start thinking like, how am I going to handle this? This is really difficult.
Yeah. You don't want to put someone through those days of bashing your head against the wall that maybe you've faced.
Yes, it's more about balancing productivity, performance, etc. in a better way, instead of, hey, we're going to favor performance completely over everything else, or we're going to favor usability, etc.
Yeah, I think this is one of the essential hidden tasks of a language designer, to say how much will I ask of the user, and how much power do I give them in return? What's the trade-off of learning versus the long-term payoff?
Yeah, exactly, and that's it's a difficult, probably one of the most difficult parts of building a language is that, well, figuring that out is difficult in itself. But you can ask 10 different people their opinion on it, and you'll get 10 different opinions back.
Yeah.
Possibly even more, depending on sort of how many times you ask them in a certain time span.
Yeah. Sometimes people wonder why there are so many programming languages, but given the number of opinions about how they should work, I'm sort of surprised there are as few as there are.
Yes, and I'm not surprised there are as few as there are, because it is, having gone through it myself, it's a difficult process. And sort of what I've seen, there are a lot of people who build a quote unquote programming language, but what they do is they build a parser and then they sort of give up, because then they realize that, everything that comes after is actually the hard part.
Yeah.
And it's also very time consuming. It's not particularly rewarding in that sense, because you can spend 5-10 years building on it and have 5 people using it.
Yeah.
So I feel for a lot of people, they'll play with it for like a day or two. So, I'm going to write a language, and then they give up and never look at it again. And I think also a big part is just a lot of the literature is not particularly accessible. An example there is I spent, I think, 2, 3, 4 months maybe working on Inko's pattern matching implementation.
Oh, okay, yeah.
And most of that time was basically spent trying to sort of digest the existing literature and try and figure out, okay, how does this actually work? What is this paper actually saying? Because a lot of these papers, they'll throw formulas at you and lots of basically Egyptian hieroglyphs,
Yeah.
and they're like, "This is easy," and you're like, "I don't understand any of this."
Yeah, there's this whole sub-language that you have to learn before you can understand the papers. And it's
Yes.
very hard to learn that sub-language because everyone writing those papers assumes you already know it.
Yes, it's the papers are written for PhDs basically. They're not written for the average developer that's banging rocks together. So in that particular sort of experience, I ended up setting up this GitHub repository that implements 2 particular algorithms and tries to sort of explain how they work. One of those is the one Inko uses, and that proved useful because, for example, the language Gleam, they based their pattern matching implementation on that particular implementation as well.
Oh, interesting.
And it's a bit funny because I can go. A while back, I went through their issue tracker and I saw a bunch of bug reports for their pattern matching implementation. And I like double checked. I was like, oh, damn, Inko also has these because they're based on the same algorithm, and the algorithm has the bug. But so that's where I sort of one thing I've been doing as part of building a language is try and figure out how can I sort of share this knowledge so that hopefully other people going through it, they have it a little easier.
Yeah, because there are a couple of artifacts that can come out of building a programming language, right? There's the language itself, but there's also the knowledge to be shared.
Yeah. I think the most frustrating thing there is a lot of the times there are certain topics that are generally difficult. Like pattern matching is one of those things where, from a technical perspective, the code is not that complex, but it's difficult to understand because it's a recursive algorithm. And those always get you. But then other parts are very straightforward, and you look and you're like, why is it not explained better? So this thing I recently did, for example, was implementing a code formatter. And there's some existing literature on it, but it's basically some papers and 1 or 2 blog posts. So there I also went through that process, implemented it, wrote an article on it, and in the end you look back at it and it's like, okay, that was actually quite simple. why was this not explained better?
Yeah. One thing I've learned from reading, not a huge number of papers, but enough to realize that the other thing is not all paper writers are created equal. Some of them are much better writers than others. Right?
Yes, so the paper Inko's memory management model is based on this from 2006. Interesting enough, Vail, which was also discussed a while back, they based it on the same paper. They essentially just went the different direction that Inko went.
Okay.
So they sort of branched off in different parts. But that paper was written, as far as I understand, not so much by a academic, but by just a developer, essentially. Papers, the author is Adam Dingle, and he co-authored it with David Bacon from various garbage collector papers. And that paper is very accessible. It's very straightforward to read. And it's almost more like a blog post in that sense.
Yeah.
But then you read papers about, pattern matching, and it's written by, PhDs with a mathematics background. And on like the first page, they bombard you in funny symbols, and you're like, "Oh God, this is
Which
going
are
to be
utterly ungoogleable, right?
Yes.
Yeah.
I have a book that's supposed to help explain them, because at some point I got so fed up with it. So it's this little book where it explains, hey, these symbols mean this or that.
Yeah.
That works, but the problem is sometimes people decide to change the meaning of those symbols in papers. And sometimes what happens, they'll write paper A, they'll use a symbol with a particular meaning, and they write paper B, and the symbol is used again, but with a different meaning. So there's no sort of reusable syntax. There are conventions, but they're not always followed. And yeah, the symbols are not Googleable, because you enter them in the search engine and you get some page about Unicode symbols or something.
Yeah.
Maybe a Wikipedia page if the symbol's frequently used, but it's a painful experience, unfortunately.
Would you have any tips for someone that wanted to write their own language?
Oh gosh, I can think of a few. So one thing I did, for example, early in the development of Inko, is that I completely set aside the syntax, because that's something where every paper on compilers, every course on compilers, they start with parsers. So I have a couple of books. They're like 800 pages. And the first 300 are all about parsing. And parsing is the most boring topic you can start with. Like that's how you burn out on building a language. So what I did with Inko in the very early days, the syntax was a Lisp, technically as expressions.
Yeah.
And I just, at the time, the compiler was written in Ruby, and I just used some library that supported parsing as expressions. And I used that to basically prototype what was at that time the interpreter, as well as standard library. I kind of get a feel like, okay, now how do I want to implement these various bits and pieces without having to argue over, am I going to use fn or fun as the function keyword, or am I going to use def, or
death by bike shed.
I didn't want to care about that at that point. So I think that's a definite thing to look into. It doesn't necessarily have to be a S expression syntax. It can be any existing thing. But the benefit about S expressions is that they're trivial to parse and quite extendable. Just not very pleasant to read. For other parts, it's more difficult because it kind of depends on the subject. So, for example, if you want to implement pattern matching, I would suggest people look at the material that I published. But outside of that, it's basically like, sorry, this is going to be difficult. I think in the context of, say, a compiler, Inko currently uses LLVM. I'm not a huge fan of LLVM for various reasons. But the alternative is basically you write your own code generator, your own linker, etc. And that can be very interesting if that's what you want to do, right? If that's what you want to innovate upon, go for it. But I think for many people, if you're more interested in building a language as a whole, I would just stick with, say, LLVM or some existing library, rather than try to build everything your own. I guess, in other words, what I'm saying is to sort of incrementally make things your own. So you sort of know where to choose. Like, instead of saying, hey, I want to write my own compiler, my own standard library, my own linker, et cetera, et cetera. It's like, no, just pick one thing, start there, and then sort of gradually work your way through it, because otherwise it's going to take 20 years to finish.
Yeah. So it's just like regular programming. You choose your version 1 features and save other stuff till later, right?
Yes. Yeah. Knowing which battles to pick, basically.
Knowing which battles to pick is half the job of any creative act. So, speaking of battles to pick, then, so this is another thing that comes back to this idea of how much do you ask of your users versus how much you give them. Because I think there are some things in programming that would have been a real mental leap a while back and are now so much more familiar that they're almost expected, like pattern matching. It's like, so why don't we talk about channels and your implementation of channels? Because that seems like an idea that's mostly mainstream now.
Right.
It's not asking people too much to use channels, but what do you add that's new?
So in case of Inko, the channels themselves are as you would expect. Like they're bounded channels. That's it. There's not really anything you can necessarily, I think, innovate there specifically.
Okay.
Prior to that, like Inko didn't always have channels. In the past, the implementation was more like Erlang, where you would send messages directly to processes and they would have a mailbox, which is effectively a channel just with a single consumer.
Mm.
So the implementation itself is similar to what you find in, say, Go or Rust, where it's a multiple publisher, multiple consumer channel.
Okay.
I think if you sort of look at it, okay, we're building a language for concurrency. What primitives should it have? There indeed is a standard set that you have to have, which is either channels or basically mailboxes.
Mm.
I would go as far as to say channels and not mailboxes, because the problem with that sort of Erlang model where you have a process and everybody can send it messages, and at any time it can receive them, is that it's very difficult to statically type this. I spent quite a bit of time on this and ultimately gave up. I think Gleam is trying to do it. They have it to certain restrictions, but they, as far as I understand, they have parts where you have to sort of escape to, I don't know if it's fully dynamic typing or gradual typing. Either way, there's sort of an escape hatch you have to make use of.
Right.
And that is because if you can receive at any arbitrary point in your code base, the compiler cannot know what the types are that it can receive at that point.
Yes.
There are some mechanisms like session typing, where it's essentially you describe a state machine in your type system. So you say, hey, we start in state A, we can then receive values of these types, and then we transition to state B, etc.
Mm.
But as far as I know, that hasn't really left the sort of academic playground, if you will. I don't know of any serious languages that use it. I looked into it and concluded that it's just too difficult to wrap your head around.
Okay.
So that's where, like, I think as far as concurrency primitives go, channels are an absolute requirement. And that's because they are a sort of first-class type, and because you can pass them around, you can solve the whole problem of what types can we receive by just saying, well, you have a channel of an int, so you can receive an int, right? There's a so if the context is known at all times. Other than that, there are various other primitives like atomic reference counting of like immutable data structures, for example, futures or promises, as they're sometimes called. These are, it depends a bit more on sort of what language you're building, I guess.
Right.
So, for example, atomic reference counting of immutable data is quite useful. Something where, in case of Inko, I'm occasionally contemplating adding it. It's usually if you have this big data structure that you want to have available to multiple processes, but you don't want to move it around or copy portions of it. You just want to read it. Like, doesn't matter.
Yeah,
right?
like a global static database.
Yeah, essentially. Futures and promises. Inko used to have futures. Its model. Essentially, what Inko has, you have your normal types. You have processes. Processes are first-class types. You define them like a regular class. You just stick an extra keyword in it. They have state, and then the way you sort of control a process is similar to a iterator, where instead of it, you start it and it starts doing stuff, you have to tell, hey, run this thing. So the way that works is you have methods defined on the process, and you can call them. And what it actually does, it sort of sends a message and say, hey, start running this at some point. And he internally uses a queue for that.
Okay.
Now, it used to be is that you would send this message and you'd get back a future. And you could then resolve that into whatever the underlying method would return. Yeah. That was replaced basically by channels. So now the methods defined in a process that you can call, they cannot return a value. The compiler will tell you like, hey, can't do this.
Yeah.
And that's mainly because futures are quite nice if you have this case of run this single thing, give me a value back. But they are kind of annoying to work with if you have, let's say, 10 futures.
Yes.
And you just want to get data as they come in and present it.
Yeah.
Because you need essentially a polling mechanism. And you end up with kind of the same problems that the poll system call has, where as the number of futures increases, so does the time to get the data. Because for 10 futures, that means you have to check 10. For 100, that means you have to check 100, right?
Yeah.
In contrast with a channel, you just check one thing. You sit there and wait until something comes in. So it's it scales much better as the number of producers and consumers and such goes up.
Yes. And if you can cope with the fact that you lose the direct connection between the thing you send and the response you receive, then channels are basically a generalization of futures, right?
So essentially, futures are a channel with a size of 1.
Yeah.
Right.
One-shot channels.
Yeah. And so in its current implementation, that's essentially what you do. If you have a case where a process needs to communicate a result back, you just say, well, here's a channel, send it over that channel, right? And maybe at some point I'll introduce a dedicated future type for that particular use case. But it's not really necessary. So I think as far as concurrency goes, you absolutely need to have something like channels. And within the type system, you need to have something that you can use to guarantee that it is safe to move data between your tasks.
Yeah.
And possibly share them if that's what you want to allow.
Because channels potentially could be an excellent place to create data races.
Yes. So in Go, for example, channels themselves are thread safe. In that, if multiple threads put something in the channel, it's not going to blow up. But the data sent over is unsynchronized. Yeah. So you have to remember, like, oh wait, we can't just send an array over. We have to send over. Well, you can if you can somehow guarantee it's only used by one case of Go routine at the time. But you have to think about, like, okay, wait, do I have to use a mutex here, or do I have to do something else? And that's where if you bake that in the type system, that's not something you have to then think about at runtime.
Yeah. Yeah, that's it's the kind of thing where I definitely see a case for the language designer adding support to stop you shooting yourself in the foot.
Yes. And I think that's what we're seeing with a lot of new languages, fortunately, is that they are focusing more heavily on that. Whereas if you look at many of the existing languages, Python, Ruby, Java, Go, etc., they basically say, hey, we have threads, we have some primitives, figure the rest out yourself. And in case of, Python and Ruby, that kind of works because they have a global interpreter lock, although Python's working on getting rid of it. In case of Java, they don't have a global interpreter lock, but that does mean you have to keep in mind, like, oh, this might be used by multiple threads. How are we going to deal with it?
Yeah.
Go there is an interesting because it has this heavy emphasis on concurrency. But then, at least in my opinion, it feels a bit like they kind of dropped the ball. Because they didn't do anything to really make that actually memory safe. But yeah, so a lot of new languages, they seem to be, fortunately, focusing more heavily on that and trying to bake it into the language so that you can't really work around it.
Yeah, but again, it comes back to this idea that if you give people more control, but you want to keep them memory safe, how much do you have to teach them? Do you have personal opinions and instinct for how different Inko is allowed to be?
That's a tough one. There definitely is this thing commonly referred to as a strangeness budget.
Yeah.
This idea that there's a certain amount of weird things you can put in your language before people kind of throw up their hands and like, this is too much.
Yeah.
I don't have, and I don't know if there really are any sort of universal guidelines for that, because it's also kind of influenced by sort of what way the wind is blowing, so to speak. So because of historical reasons, for example, Lisp-like languages are kind of out of favor. And so you can build the best programming language in the world, but if it's a Lisp, people are like, not really sure about this. All these parentheses, this looks weird.
Yeah. Not necessarily agreeing, but I think that's an accurate representation of the state of the industry.
Yeah, and so it kind of varies, by time and various other factors. I think, I actually don't have good tips. It's I would say, it's a matter of taste and guesswork, but that's terrible advice because it's very abstract.
Yeah, it's hard to act. Well, let me put it in a more concrete way. So is this one reason why it seems to me Inko has very ordinary syntax? I mean, it's exceptionally familiar to anyone that's written Java or JavaScript with classes.
Yes, so I think that stems from the sort of original setup where I had a as expression syntax. For me, syntax is not really an interesting topic in that there are certain things you can sort of explore, but I think for the most part, we've sort of exhausted the things you can try out. And so if the industry as a whole is kind of settled on curly braces as sort of the main thing of, say, indentation and sort of class structured setup for types and such. So because of that, one of the things I wanted was a syntax that is just really simple to parse and really simple to wrap your head around. Part because I don't like writing parsers, so I just wanted to spend as little time possible on that.
I'm getting that sense from you.
Right. Part because they are written by hand. I'm not using parser generators. But part of it is also, I think, fueled by my experience working with Ruby for many years, where the syntax is this weird monstrosity that kind of like a hydra keeps growing a new head every year. Where every year it's like, oh, there's this new syntax feature, this new this, that. And for a while, I was helping out with this library that exposed a parser of Ruby for the various different versions. Because Ruby standard library has a parser available, but it's directly tied to the version of Ruby that you're running. So you can't say, hey, no, we want to parse syntax for this particular Ruby version up to whatever. It's like, no, it's always the latest. And the API is just a pain in the butt to work with. And so there's this library, and I helped out with it. And the main developer was basically just having sort of an increasing number of mental breakdowns over time, just because the syntax kept changing. And they were like, we just fixed this, and now we have to deal with this other thing. When does it ever end?
So you've been bitten so badly, you want to go to the opposite end of the syntax argument.
Yeah, and the result of that basically is that in Ruby, it's very difficult to write proper tooling that acts upon the syntax, because it's so dynamic and like ever changing. And so with Inko, I was like, that's exactly what I don't want. Like, that's something I want to avoid. I want people to be able to write different tools and focus on what the tool actually does, rather than how are we going to parse this syntax. And I think also part of it's just a sort of byproduct of trying to not put too many things in it. Put this way, I think I'm very good at saying no. Like if you look at a lot of languages, it seems the sort of answer to a lot of proposals is basically like, oh yeah, sure. Whereas my standard response is like, no, we're not doing this, right? So if you look at Rust, for example, when I started using it in 2015, it was, I wouldn't say simple, but it was definitely less difficult than it is today.
Okay.
And for example, I recently learned that there's this proposal so that you can embed a cargo manifest inside a Rust file. So kind of similar to Markdown, there's this idea of having a sort of front matter section in your file.
Okay.
And I kind of looked at it, I understood why people were pushing for that. But my response, like, why are we embedding, in this case, Tom L inside Rust? Like, to me, that seems absurd. And similarly with, there's a proposal to have essentially const generic keywords or something, where you could have functions that are generic over being async or not, things like that.
Right.
And they're all features that, when I look at it, they make sense. I understand why people reach those decisions. But my response is like, no, I want something simpler. And I'm willing to basically say, look, we're just not going to do X, Y, Z because of that.
It's worth keeping the footprint of the language small, even if you sacrifice everyone. Even if you sacrifice the chance of pleasing everyone.
Yes. So I think my sort of approach there is, I know you cannot please everyone. Like, even if you have the perfect language, somebody like, well, actually, it doesn't do this, one thing, so I don't like it.
Mm.
And so my approach, like, I'm not interested in pleasing everyone. I want something that's more approachable and easier to use, even if that means that certain things are perhaps not as efficient as they could be, or as generic as they could be, or whatever it is.
Yeah. I can see people. I can see plenty of people responding to that. Plenty of people who feel that some languages have too large a footprint, and liking that. So before we get off the technical side of this, there is one language feature which I'm reminded of by talking about problems and how difficult life is or not, which is error handling. Because I know that's a battle you have chosen to take on. What's Inko's perspective on error handling?
Let me see how I break this down. So, there's an article written by Joe Duffy. It's called The Error Model.
Okay.
And it's this article in which they basically break down how they did error handling with this project called Midori, a language they were developing at Microsoft. And it breaks down sort of the different approaches they tried, the trade-offs, etc. Inko's model is inspired by that, although it has changed a little bit. Essentially, the way it used to be is that a function had a return type and a error type. And you could throw it, then it would be an error. You could return it, then it would be a normal value. And then the compiler would ensure that, hey, if a method has a type that it throws, you are forced to handle it at the call side. So there's no implicit sort of unwinding across function calls. And you could only specify a single type to throw. So you couldn't have a method that throws, an int string, an array, all these different things. It's just one thing.
Okay.
And there were a couple of other restrictions, but it basically meant that you wouldn't have this problem in typical languages with exceptions where you call a method and it might throw 25 different errors. Some it might throw directly, some might come from 10 function calls deep. That model I have since sort of moved away from, and now it's using basically algebraic data types like enums, result types, etc.
Okay, yeah.
And that's because although that first model is very interesting, it's quite efficient. If you don't support implicit stack unwinding, because it means you always only have to basically return. That setup, producing an error is basically you set an error flag and you return a value. That's it. There were no stack traces built or anything like that. The problem with that approach is that it doesn't compose very well. So if you have, say, a case that I ran into quite frequently is you have an iterator and you have some sort of map operation. The code running in that map might want to throw an error, but then pose the question, like, when you define that map function, do you allow that to throw errors? How are you going to sort of propagate those back up? And you basically end up with this pattern where a lot of functions end up having a generic throw type just so that they can throw whatever a provided closure may throw.
Yeah.
And it's essentially because you now have two output streams, your return output and your throw output. Whereas if you return, say, a result type that can be either OK or an error, that automatically composes with everything that handles return values. So your map functions, your folding, etc. And so that's what Inko uses now, basically, because it composes easier, and because you can pattern match against it. It's more expressive.
So your perspective is that algebraic data types are better than two separate channels, one for results and one for errors. They subsume them. Algebraic data types subsume that specific syntax.
Yes, I am willing to die on the hill by saying that algebraic data types are better than exceptions in any form. Because of the performance, because they compose better, you can pattern match against them. Now, there is the concern that it has a performance impact in that you have these values that you have to sort of unpack. So every time you handle them, it's like, hey, are we dealing with an OK or an error? Okay, you do this, do that, etc.
Yeah.
But that exists anyway, even if you use some form of exceptions, because as you call a method, you need to check, hey, did this throw a value or not?
Yeah.
And that can be an explicit check. That can be some sort of unwinding magic that's potentially expensive. So there's always a cost there. But that cost you can optimize away. You can, instead of allocating these result types, you can put them on the stack. Maybe through clever inline optimizations, you can get rid of most of it in the first place. So it's, I think, in the long term of a language, that's not that big of a problem.
Okay, then a related question. Are you going to say that, I think I've almost got you to say that channels should be part of any language. Are you going to say that algebraic data types should be part of any language?
I think, for pretty much most, yes. Okay. In the sense that I will admit that if you have a dynamically typed language, their value is a bit questionable. Because you can use dynamic typing in that case. You can say, oh, this function returns an array or nil or something.
Yeah, you sort of have it anyway, right?
Yeah. And also in a dynamically typed language, there may be less opportunity to optimize the cost of algebraic data types away, depending on whether or not you have a JIT compiler, etc. But at least for a statically typed language, I would say yes. It's very much... I think you can get away with not having it, but I think you'll make a lot of people happy by including it.
Yeah, it's definitely one of those things I look for when looking at a language. And
yeah,
I'm not saying I rule a language out if it doesn't have them, but it raises a question mark if it doesn't have them for me.
Yeah, I think it's interesting. For example, Zig, they have an interesting error handling approach where, if I remember correctly, essentially they are like you annotate a function with, hey, it might throw, I think, a value of a certain type, and then they sort of generate like error codes. But the problem there is, as far as I know, you cannot attach additional data to the error. So you can say, hey, this will throw, 1, 2, 3, 4, 5, but we can't attach, say, some sort of information that describes the location at which the error occurred, or any additional metadata. And this is something where I've seen people bring this up and say, hey, I like Zig, but it's kind of annoying that I can't attach extra data to my errors. And so I think they're not required, but definitely very nice.
Yeah, I would totally agree with that. Okay, so moving on from the technical side, because there is one other big question I want to ask you. We've talked a lot about if someone wants to write their own programming language. There is a big practical question if you want to create a programming language, which is how do you fund it? And there are a number of funding models, and I know yours is interesting. So I wanted you to tell me about that.
Funding is difficult. At the foundational level, it's basically going to be donations, because whereas in the 80s and 90s, people might have been willing to pay for programming languages. Nowadays, that's not true anymore. Nobody's. If you produce a language and you say, hey, this is going to cost you $100 a month or whatever, people are like, yeah, nah, I'm just going to use Python instead.
Yeah.
And so that means you basically have as your options donations, a sort of side hustle of some sort, or sponsorship. Sponsorship typically only becomes relevant if you're big enough, because some random company is not going to say, hey, we're going to fund a bunch of people to work on some random language.
Yeah.
So for most cases, it's, donations or a side business. That side business can be some sort of support construct where you see with a lot of open source. It can be a business that makes use of the language. The challenge there is if you do something on the side that makes you money, I suspect that will become your primary interest, because that's what's paying your bills, basically. And I suspect it's going to be quite difficult to sort of balance between working on the commercial thing and the language that it's built on top. Might be more possible if you start hiring people, but then you need more funding, which probably means venture capital, which sort of completely changes the trajectory you'll be on.
Yeah, very much so.
Like, for example, Dino is doing this, where they have a language, and then they have a whole business built around it, like a key value store, hosting, etc., etc. And that can work quite well, but I don't think you can do that as a solo developer. I think it's just too much work. So you have to be willing to say, hey, okay, we're going to hire people, we're going to take venture capital. That means we're going to have to go public. That means a lot of the decisions are going to be influenced by shareholders, because they want at some point their money back.
Yeah.
Right, so your language goes in a completely different way. Donations are very, very difficult. Like, you can build the best thing ever, and people will still not pay you money. Sometimes that makes total sense because they don't have it. Perfectly reasonable, right? Other times they're just like, well, I already use Python, so, right? The reasons can vary.
Yeah.
And what I've noticed so far is the sort of traditional ways of going about it is you publish stuff, articles, papers, whatever. And through that, you try to sort of constantly remind people, like, hey, this thing exists, please take a look. But what I've noticed myself is that you can publish something, and let's say you get 100,000 views or something like that. Of those 100,000, maybe 1,000 will actually click on the link to the website of your project. And of those 1,000, maybe 10 will actually try it out. And of those 10, maybe 1 or 2 will join your Discord, IRC, whatever channel.
Yeah.
And then of those, maybe 1 will donate. So the conversion ratio of basically people seeing it to people donating is very, very low.
I can believe
and that means it can take many, many years before you get, I don't know, $100 a month, let alone enough to pay your bills.
Yeah.
I don't have any sort of good ways about dealing with that. I'm still trying to figure that out myself. There are organizations that you can apply for grants. So Inko has that. There's a grant we get from a foundation called NLNet, a foundation here in the Netherlands.
Yeah.
They're sort of an annual grant dedicated towards primarily projects that are sort of internet focused.
Okay.
Inko in that sense was a bit of an exception. Essentially what happened there is I asked for about 8,000 euros. The idea being that I think it was like 1,500 or something a month to take into account my bills, taxes, etc.
Yeah.
And I thought that was a lot of money. So I was like, ooh, they're probably going to reject it. So I had a call with them and they basically said, look, normally we don't really do programming languages because there's already so many of them. But the amount you requested was so little that we figured, hey, you know what, we'll give it a try. And I was like, okay, what do people normally ask? And they're like, well, 50,000 euros. And I was like, oh, okay, right. But the thing with those grants is they are typically sort of very specific to certain topics. So the European Union has a couple of grants that you can apply to, but they're usually focused on like security or I don't know, dealing with artificial intelligence. Like they're very specific, and if you fit within that profile, it's probably great. But for most people, I suspect they will fall outside of it. And this is something I'm still trying to figure out. Where Inko's funding has sort of gone up and down a bit over the years. I think at peak, the donations were like $40 a month before taxes. Currently, it's stopped at zero because a bunch of people they stopped their donations. I think a ideal solution would be some sort of system where governments they dedicate a certain amount of their annual income to these sort of funding organizations, to sort of let's call an open source tax, if you will, so that there's basically this constant stream of money that isn't purely tied to the goodwill of companies and organizations. But I think it will be many more years before we will see something like that, if at all. And I think even if we see it, it's going to be maybe one or two countries. I doubt it's going to be widespread. So,
yeah, there are certain countries I certainly can't see that happening in, despite the fact that I do think if companies gave back in cash 1% of the value they get from open source, that would make a huge difference.
Yes, that's the sort of paradox where I don't know if it's a paradox, but because it's open source, people don't pay for it. But if you charge people for it, they will not use it because they don't want to pay for it.
Yeah, no matter how valuable it is.
Right, and you end up with this sort of state where, a lot of companies are built on top of open source software, but that software is not receiving funding or very little. OpenSSL is probably the best example. When Heartbleed happened, people realized, it's basically one maintainer, and they've been getting like basically no money or very little for many, many years. And now we have this big problem. Shoot, maybe we should send some money that way. And I believe nowadays they have a decent amount of funding as a response to that. But there are a lot of projects where that doesn't happen simply because they don't have that sort of big exposure event where people sort of wake up and they're like, oh, shoot, right?
Yeah. And it wouldn't be ideal to manufacture that, right?
Yeah, an ideal way, people would be, like, companies would have to set aside some money, but it's very difficult. I don't think that's going to happen at a global level. And there is the potential problem that if that happens, companies might say, well, we're just not going to use open source anymore. We're just going to build it all ourselves, right?
I think if they did that, they'd very quickly find out that paying for a bit for open source is the cheaper route.
Right, probably.
Yeah.
So I would like there to be more billionaires donating money to open source, similar to how they all set up their own, trust funds and whatever. They just throw some money towards things like the Apache Foundation or whatever exists, right?
Yeah. Yeah.
The unfortunate reality, I think, is that especially if you build a language, you have to be willing to accept that for at least 5, maybe 10 years, your income is basically going to be zero, or at least very close to it. Which means you need savings, you need, a partner or family that can support you, etc. I was very fortunate. I can afford this, in that I set aside money to fund this, and I made various decisions in mind, keeping in mind that for the next, I don't know how many years, my income is going to be very bad. But that's very much an exception, and there's still that sort of thought, like, okay, at some point we have to admit that I have to start making money again, right? Because money is not infinite.
Yeah.
So yeah, it's a struggle. That's basically the gist of it.
As an independent podcast producer, that's a familiar story. But until the day that the billionaires start reaching into their pockets, the utopian future, for the present, let's try and end on a happy note. If someone wants to play with Inko, where do they go, and how ready is it to play with?
So they can go to the website. There's also there's links there to the GitHub repository, the Discord, etc. In its current state, it's very much usable. You can write stuff with it. I have a couple of projects written with it. For example, it controls my central ventilation system.
Cool.
I would recommend people to check out the Git repository instead of the current stable release, because there are a couple of changes there. So it is very much accessible. I think the main limitations currently is that SSL sockets are not supported. So if you want to do like HTTP connections and such, you have to use curl, for example.
Okay.
But beyond that, it's very much accessible.
Worth taking a spin for.
Yeah.
And see if it is that friendlier step away from Rust, but towards the metal, right?
Yes, I certainly hope so. The feedback so far has been very positive. So the sort of inner critic in me is being sort of kept in the corner, like, no, we're doing all right.
Well, we'll leave people to go away and check it out. And if they like it and happen to be billionaires, get in touch with the show and we'll get Yorick's bank details for you.
I mean, there's a GitHub sponsors account set up, so you can donate straight to GitHub.
Even easier. How am I going to get my 5%? Yorick, thanks very much for taking us through it.
Yes, pleasure being here.
Cheers. Thanks, Yorick. So if you're listening to this from your computer or your phone, you'll find links to Inko and some of the writing that inspired it in the show notes. And if you're listening to this from your yacht, you can contact us directly with funding opportunities. You'll find our contact details in the show notes. Of course, for the rest of us, the first currency of the internet is interaction. So if you've enjoyed this episode, please hit like, share it with a friend, leave a review on Apple or Spotify. And of course, if you're not already subscribed, consider clicking the subscribe button, because we'll be back next week with another great guest. Until then, I've been your host, Chris Jenkins. This has been Developer Voices with Yorick Peterse. Thanks for listening.